All right, we're going to do some inverse trig function integration. So our outcome is I will integrate inverse trig functions. We've already done derivatives, so this is just reversing it. And the good thing is we only need to know 3. Okay, so let's just review. What does inverse mean anyway? Inverse trig functions are where you're reversing. Inverses are where you're switching your x and y, your domain and range. So we know when we did trig functions, like the sine of pi over 6 is a half. So what if I started with the 1/2? That would be an inverse trig function. So here are 3 forms of that. You can do arc sine, inverse sine, or this is also inverse sine with the -1. All right, so you're doing the arc sine of a half. So that's meaning who on the unit circle has a y coordinate of a half? And the answer is the angle pi over 6. So that's where we're switching it. Instead of knowing the sign of the angle and saying that the y coordinate on the unit circle at pi over 6 is a half, we're doing, okay, who on the unit circle has a y coordinate of a half? And we say pi over 6. Now, I know there's 2 answers to that. So that there's domain restrictions for the inverse functions, all right, so that you only get one answer. All right, but that's what we're doing. We're switching it to where we know that the answer to the coordinate, and we're trying to tell the angle. That's inverse trig functions. All right, so now we're going to do the integration of that. All right, so on the left is the generalized ones, or not generalized, the ones on the right are the generalized ones. The ones on the left just have a 1 in it. So you're just doing the basic function arc sine of x, arc secant of x, arc tan of x, just like sine x, cosine x, tangent x. So we're only dealing with just an x. All right, so in order to get just an x in your arc sine, arc secant, it has to have a 1 in front of it. So it's 1 over the square root of 1 minus x squared. All right, and here x squared minus 1 and 1 plus x squared in the bottom here. So these are the simple ones. Over here are the ones that are generalized for everybody. So notice the difference. The 1, instead of being a 1, this is a squared. All right, so that means we may not always have a 1 inside our square root sign. It may be a 4 minus x squared. In that case, a would be 2. All right, so, and then the second part is the x squared. We may just not be dealing with an x. Remember, we may be dealing with a more complicated function. Like this may be, 5x inside here. So it'd be 5x quantity squared. So we may have a function in there instead of just an x and dealing with x. So these are going to be what you think of when you're doing your u substitutions. All right, and so these are just little formulas. So whatever a is, it's going to be u over a for your arc sine. So in this case, a was 1, so it's x over 1. Okay, so we're going to be concentrating, though, more on the right side ones, because that's how I'm going to present them or go through it, because we're going to do a u substitution anyway every time. All right, so what I want you to notice is the difference in the 3 of these. For sine, it's the square root of a squared minus u squared. And then for arc secant, it's the square root of u squared minus a squared. So the u comes first. But it also has a u on the outside of the radical. So to me, that makes it easy to remember. The one that has the u on the outside starts with the u squared on the inside of the radical. Pretty simple, I think. And then 1 over a squared plus u squared, that doesn't have a radical at all, and that's arctan. So if it doesn't have a radical, you're talking about arctan. All right, if it's got an extra thing on the outside in front of the radical, that's arc secant. And if it doesn't have anything and it's just got a radical in it, then it's arc sine. And notice arc sine does not have the fraction. Arc secant has 1 over a, and arctan has 1 over a in front of the answer to the integral. All right, to the antiderivative. So we're just basically going to be looking at these little rules. And there's only 3 because there's normally 6, but these are the only 3 we have to know. All right. All right, let's just go straight into the examples instead of having a separate content video this time. All right, so looking at this first problem. If you notice, there's a radical and the numbers in front. So to me, this looks like an arc sine problem. So if I'm looking at arc sine, all right, the rule for arc sine was 1 over the square root, and it had a squared minus u squared du, and that equaled, without a fraction, that equaled arc sine of u over a plus c. Okay? So if I'm just comparing this to the problem I have, I know my a is 2 because it's 4, so a squared is 4, so that means a is 2. And then our u is just x because it's minus u squared. We have minus x squared, so u is x. And then du equals dx when you take your derivative like you do with the u substitution. Now, whenever you get du equals dx, then this is a straightforward, simplest problem we can have because this directly matches with the problem we have. So then we can straight up just substitute in here and we're done. So our answer is arc sine u over a. So u over a is going to be x over 2. And then plus c. And I'm done. That's my answer. Because it was a straightforward problem with the du dx. All right, now let's look at this one. All right, this one I don't have a radical. So to me, that's looking like the arctan. So the arctan one was 1 over a squared plus u squared du equals 1 over a arctan u over a plus c. All right, so there's the rule for arctan. So if you have these in front of you, it's real easy to do. So when I'm looking at this, I'm comparing the two together. Now you can think of this dx as being over the side right there. It doesn't have to be right there. And then that means there's a 1 in this numerator. Okay, so the dx can be on the side. Now, I've got the 1 in there, so if I'm looking at this, my a squared is 2. So that means a must be the square root of 2. All right, and then plus the u squared. What do I have to square to get 9x squared? So the u must be 3x. Because if I square 3x, I get 9x squared. So u squared is 9x squared, so u has to be 3x. So then I'm going to do my derivative. So du, just like we do with normal u substitution. So du's got to be a 3 dx. And then I'm going to solve for dx here. So we're going to divide both sides by 3. All right, so my dx equals du divided by 3. So this is almost a straightforward problem, not quite. I have a little extra 1/3 in here. All right, so we're going to trade out. So let's change I'm going to do a u substitution. I'm going to trade out my color here. So when I do this, I'm going to have the integral of 1 over, all right, this was square root of 2 squared plus, and this was 3x squared, and then the dx. So I'm just thinking about this here a minute. All right, so if I trade this out and look at what I got here, I got 1 over, the square root of 2 was my a, so that's a squared. And then the 3x, that was my u, so that's my u squared. And in place of the dx, I'm going to put du over 3. All right, so the only thing I have, if I compare it back to this rule up here, the only extra thing I have is this 3 on the bottom. So when I do my antiderivative, change back to blue. When I do my antiderivative, I keep the 1/3 because that's the coefficient. And then all of this matches perfect with this. So that means my antiderivative is this rule right here. I'm just going to have that extra 1/3 in there. So it's 1 over a. So my a was square root of 2. And then arc tan. And then arctan of u over a. So u was 3x over radical 2. And then plus c. So there's my answer. The only extra thing that we could do would be multiply out the 1/3 times the radical 1 over radical 2. Write that 1 over radical 2 as radical 2 over 2, which would make it radical 2 over 6. That's really the only thing different that we could do with the problem, would be to multiply that together and make it radical 2 over 6. All right. So now let's look at number 2. All right, so if I'm looking at number 2, what I've got here for number 2, let me get rid of them a little bit. All right, for number 2, I notice I have an x on the outside, and then the x's start in the front in the radical. Well, to me, that looks like arc secant. So remember what arc secant looked like. Arc secant was 1 over u, and then the square root of u squared minus a squared, and that equaled 1 over a arc secant of u over a plus c. So all I got to do is get this guy, see who my u's and stuff are. All right. So who is my a? So it's minus a squared. So my a is going to be 3. And my u equals, let's see, u squared has to be 4x squared. So u must be 2x. All righty. So that means there needs to be a u out here. But there's not. There's only an x. And there's a couple things I could do to fix that. I could put a 2 out there, which means I'm actually putting a 1/2 here, which means to counteract that, I'd have to put a 2 on the outside. That's one thing you can do. Or we could do just straight up u substitution and keep going, not making it difficult for you. So du would equal 2 dx. I would just take my normal derivative, like I've done, because I'm doing u substitution. So my u is my 2x. And so du equals 2 dx, and then I would solve for dx. So that would be 2u du over 2. All right, so now I'm going to trade out. So let's change our color. So when I trade out, I'm going to think of the dx being on the side. So that's going to be 1 over, all right, x. Here's how I'm going to write that. All right, x is really u divided by 2. If I think of x right here, x is u divided by 2. Okay? And then it's going to be the square root of 4x squared is actually my u squared. Okay, because my u was 2x, so that'll be 2x quantity squared minus, and then 9 is actually my a squared. Okay, and then the only thing I need to trade out now is the dx. My dx is du over 2. All right, so when I'm looking at this, notice this 2 cancels this 1/2 over here, because this is u divided by 2, and then this is times by 2 here. So this 2 cancels this 2 right here, okay, because that's a 1/2 times 2. All right, so now it matches perfectly. 1 over u, square root of u squared minus u. It matches perfectly with what the rule is. So I can just fill it in. So this is going to be 1 divided by, who was my a, 3, and then arc secant. And then u over a, u was 2x, my a was 3, and then plus c. And that's my answer. 1/3 arc secant, 2x over 3 plus c. Good deal, good deal. So that was it there. I was going to see, okay, I was going to see if clearing it would be a little bit better. All right, and then going on to the next one. All right, just a pointer. I don't want anything else strange. All right, number 3. All right. So when I'm looking at problem number 3, I'm trying to think, okay, now who does this look like? All right, so when you're looking at this at first looks like it could be the arc sine, mainly because there's nothing in front of the radical, right? So when there's nothing in front of the radical, we think of that as arc sine. But if you'll notice, the term under here starts with the variable. It's e to the 2x. So I'm thinking, oh, this could be arc secant. All right, so let's just start with our u substitution and see what happens before we decide which one this is going to be. All right, so let's let u, go to my marker. So let's let u equal, so u is going to be e to the x. Now, why is it just going to be e to the x? Well, because if you take e to the x and square it, because I'm wanting this to be u squared, so e to the x squared, when you raise a power to a power, you multiply. So this would be e to the x squared would be e to the 2x. All right, so my u is just going to be e to the x. All right, so that means du, remember the derivative, we're doing a u substitution, and my derivative of e to the x is e to the x dx, okay? Then I'm going to solve for dx. So that'll be du divided by e to the x. All right, now, if I look at this and put this in here and trade out here a minute, all righty, so I'm going to have 1 over, in here, I'm going to have my u is e to the x, so that'd be u squared minus 1. And then in place of the dx, I'm going to put du over e to the x. I could move him and put him in front. So instead of writing him there, I could write him here, which e to the x is actually my u, right? So instead of writing e to the x even there, I could write that as my u, because u is e to the x. So now who does this look like this is? All right, I've got 1 over u square root. So now I've got something out in front of the radical. So this is looking like the arc secant. All right, so the arc secant was 1 over u square root of u squared minus a squared du. And that gave us the 1 over a, I'll write it over here, 1 over a arc secant of u over a plus c. All right. So now all I got to figure out, I've got my u is e to the x. So then the other thing I got to figure out is what's the a. So that's easy. This is u squared minus a squared. So that means my a is just 1 because it's u squared minus 1 squared. So a squared is 1, so a is 1. So this is not that bad a problem. All right, so now I'm just going to fill it in. I'm going to change to blue. All right, so I'm going to use this rule. So it's 1 over a is 1, and then it's arc secant of u over a. So my u is e to the x, so that's e to the x over 1 plus c. So this ends up being simply arc secant e to the x plus c. So at first, it looked like it was arc sine. All right, it looked like arc sine because there was nothing that was in front of the radical in the denominator. But I noticed I had my variable coming first. So that's kind of what makes you think that you have arc secant, is when the variable comes first, when the u squared comes first minus the a squared. So then I just started working at it, and it ended up that because of my du and my dx, I ended up with an e to the x in the bottom, which puts me that u out in front of my square root sign. So everything turned out perfect. All righty, next one here, number 4. And there's not very many of these. I think there's just 5. So we'll go to number 4. Now, number 4 is kind of an interesting little problem. But the only interesting part about it is we need to split it up into pieces first. All right. So we're going to break it up into pieces. All right, so I'm going to break this up into x over the square root of 4 minus x squared dx plus another one and have it be 2 over the square root of 4 minus x squared. Now you might be wondering why I'm doing this. Well, I'm breaking this up because I have a radical, and it's just going to be easier to see it in two pieces, because if I put the x in my numerator, the derivative of my denominator is, or what's under the radical itself, is negative 2x. So this is going to be a straight u substitution, but I can't do that with the x plus 2 because the derivative of the stuff underneath the radical would have to be something x plus a number. And the derivative of this down here is just negative 2x. So I need to split this up because just negative 2x can't have a constant on it. So I'm breaking it up into two pieces. So this first part is going to be straight u substitution. This part is going to be using an inverse trig function. All right, because I've got the a squared minus the u squared in the denominator of the radical. So this is an arc sine. All right, so we're just going to do it as two different pieces. All right, so for this first piece, I'm going to let my u be 4 minus x squared. All right, so my du is negative 2x dx. So dx will be equal du divided by negative 2x. Okay? Now, so we'll go ahead and do both of them at the same time. And then over here on this one, if I'm thinking who this is going to be, because it's a squared minus the u squared, I'm thinking that this is an arc sine. So the rule for arc sine is 1 over the square root of a squared minus u squared du equals, now remember the arc sine doesn't have the fraction in front of it, so that's just arc sine u over a plus c. All right. So when I'm looking at this problem, now what I've got here, I've got an extra 2. So that's just going to be this thing multiplied by 2. That won't be a big deal. And so then my a number is 2. And my u value is just x. So when I do the derivative, du equals dx, because it's so simple that du equals dx, this problem is going to be straightforward, really, really simple. All right. So let's start with our antiderivatives here. All right, this first one I'm going to trade out. So I'm going to do a big equal sign here. All right, so I'm going to have x over, and then it's going to be the square root of, in place of this, I'm going to put my u. And in place of my dx, I'm going to put the du divided by the negative 2x. Oh, I put an a. Don't know why I put an a. Negative 2x. All right. Put that in parentheses so it doesn't look like a minus sign. Now notice here my x's cancel. So when I'm looking at this and putting this in order, I've got a negative 1/2. And then here, if I think about this, what this looks like as a power, this is u to the negative 1/2, because I have a square root sign in the denominator. So my fraction is negative 1/2. My function is u to the 1/2, but he's in the denominator, so that's u to the negative 1/2, and then my bookend du. Okay? So now it's very easy to do the antiderivative of this. So we keep our coefficient. The antiderivative of u to the negative 1/2, you add 1, so that'll be u to the positive 1/2. And then remember, you always divide by the power. So you add 1 and divide by your new power. But since this is a fraction, I'm going to multiply by the reciprocal, 2 over 1. All right. So there's my antiderivative for that one, looking pretty good there. All right. Now for this part, plus, we said this was a straightforward type problem. The only difference is I'm multiplied by 2 because this is a 1 over this, so I'm multiplied by 2. So since I'm du equals dx, this is 2 times this function up here with a being 2 and the u being just straight x. And we said it was an arc sine. So that'd be 2 arc sine, and then u over a. So u over a would be x over 2. And we're going to end up putting our plus c on the end here for this one. All right, so let's finish doing our antiderivative for this one. This cancels. So I'm just left with -1. So it's going to be a negative, and then it's u to the 1/2 plus 2 arc sine of x over 2 plus c. So the only thing I got to do here now is to put the u back in. So my final answer is going to be negative. U to the 1/2 is the square root of my u. My u was 4 minus x squared. Plus 2 arc sine x over 2 plus c. So there's my final answer. So the first part was just negative square root of 4 minus x squared. That was coming from doing just a normal u substitution for this first piece. And then the second piece ended up being straightforward arc sine, just multiplied by 2. So then that's why it's 2 arc sine of x over 2, and then the plus c on the end. So that's my final answer, the two pieces there added together. All right, and we got just one more left. Number 5. I wanted to do one that was a little interesting here, so we're going to do this last one. All right, so this last one looks daunting at first, but it's not that bad. All right, if you think about the rules that we're doing here, what they look like. All right, 2 of them have radicals in it and 1 doesn't. All right, one of them, the arctan, is the 1 over a squared plus u squared. Well, if you notice this down here, I can rewrite this so that it looks like an arctan. So it doesn't have a square root in it, so I'm looking at an arctan problem. So here's the rule for arctan. It's 1 over a squared plus u squared du. It equals 1 over a arctan u over a plus c. So there's the rule for arctan. I need to get this problem to look like this, okay? And I think we can pretty easy, okay? We can get it to look like that. I'm just going to rewrite this problem. Let me change to a different color. I'm going to rewrite this problem. And I'm going to be a little creative on how I rewrite it. Well, first of all, I'm going to move the dx over to the side because I know that's bothering you. All right, so I'm going to put the dx over here. Okay, so it's 1 over. I'm just going to rewrite this problem a little differently. I'm going to write it as x squared minus 4x plus 4 plus 3. So basically, I'm just splitting the 7 up into a 4 plus 3. All right, now why did I do that? Because now I can write the problem as x minus 2 quantity squared plus 3. By splitting that 7 up into 4 plus 3, I made this first part a perfect square. X squared minus 4x plus 4, that's the quantity x minus 2 squared. All right? So look what I've got. I've got an a squared. I mean, addition is just reverse. I mean, being addition, is commutative. My a squared is the 3. So right now, I know that a is the square root of 3 because a squared has to be the 3. So a is square root of 3. My u squared, my u is going to be the x minus 2 because this is my u squared. So now when I do this, du take the derivative just like you do when you do integration. Du equals, and the derivative of x minus 2 is going to be dx. So because I got du equals dx, this is a straightforward problem here. I can just do straightforward here. So the answer is going to be, I'll change back to blue. The answer is going to be 1 over a, my a is radical 3, arctan u over a. My u was x minus 2 over my a is radical 3, and then plus c. So there's my answer. All right, so the little trick was to rewrite this quadratic, split it up to where I had a perfect square plus another integer, and then writing it as a perfect square plus that integer is my a squared, and then this quantity squared, the binomial that I made squared, that was my u. And the fact that the derivative of that, du equals dx, made this a straightforward problem. And then I was just able to do the rule 1 over a, arctan u over a plus c. All right, so those are your inverse trig problems. They're on the AP exam, might have a question or two, but all you got to be able to do is recognize them, because arctan doesn't have a radical in it. Sine is a square root, has a radical in it, but it starts with a number. And then the arcsecant has a variable on the outside of the denominator plus the radical, and it starts with a variable. So, I mean, just recognizing the patterns, you'll be fine. All right, so now I've given you some practice problems to do. So now you can go practice and do a few of these. Just remember to have the rules in front of you and be able to pair them up with the rules and just plug in the numbers in the rules. Okay.